Welcome everyone, welcome to part 4 of the PowerBox iServo series of videos. So in today's video we are taking a closer look at the new iServo PC terminal program. So this program is specifically written to program the new iServos from PowerBox. Don't confuse it with the existing terminal program, which is used to program other PowerBox devices. This new software platform only programs iServos. If you need to grab a copy of this software, I suggest you post a message on the PowerBox forum and you'll be provided with a link to download the software. You can download it, you register the software, provide your email address, they send you basically an automated system sends you a registration code or an activation code I should say. Once you get that activation code, you type it into the software and it activates the software. And basically you'll get this screen that you can see here in front of us. You really can't do much with the software unless you connect an iServo to it. So at this point in time, even though I've got my USB interface connected, so I've got the PowerBox USB interface, I don't have a servo connected at this point. And all you get is basically a few fancy pictures in the middle of the screen that we can cycle around have a look at, and that's about it. Nothing too exciting. There's a few menu options up here. You can change the language, update, recover, reset, about, but yeah, that's about it. So let's go ahead and connect the servo to the software, or I'll connect it to the USB interface. And while I'm talking about connecting the servo, in my testing, what you'll need to do is connect a battery or regulated power supply to supplement the power from the USB interface, because the USB interface is not powerful enough to drive the servo correctly. It sort of works, but it's a bit flaky, so I don't recommend using it. I recommend using a 2S LiPo or a Life Cell, something similar. But I'll go ahead and connect the servo now. So the servo that's pictured on our screen, I'll connect that to the USB interface via a wire lead and the battery. And I won't show you that on screen, but I'm just plugging in a servo connector, and you'll see straight away the software reads a servo and it basically goes into the setup menu for the servo. So let's have a quick look at this software. Right in the middle of the screen we have like an hour indicator, or it's basically a position indicator for the relative position of the servo. So the software always knows where the servo is positioned because of the Hall effect sensor. Remember, there's no potentiometer, so it reads the position from the Hall effect sensor, little rotating magnet, and we can basically rotate more than 360 degrees, which I've shown you in a previous video. Now let's go across the top. We've got setup, which is this screen here, and I'll go into some of these details in a minute. We have an advanced option. Nice fancy graph there in the middle. We have a telemetry option. Don't get too excited about this screen because I'll talk to you about this later. And then we have an info screen. Maybe I'll start with the info screen. We have the servo serial number, the servo type. At the moment we've only got the HVC.45 to choose from. We have a production date. I have noticed that a couple of my servos have actually got the incorrect date here. They're listed as being produced in 2018. So don't get too worried about if this date is not quite correct. I suspect they've just been accidentally programmed incorrectly from the factory. Of interest though is these two timers here. So we have a power on time. So the servo keeps track of how long it's been powered up for. Can be handy. But more importantly, it also keeps track of the mechanical runtime. So while this servo's been connected to power for 3 hours and 8 minutes and counting, I've only sort of used it for about 2 minutes and 2 seconds with this software, so it hasn't really been used much. So these two timers are stored within the actual servo, and they obviously run when the servo is connected to a power source. And yeah, they could be handy for just getting a feel of how much work the servo's done. We have the default servo name here. We can change this name, and this appears later on in the transmitter. So if you've got the servo connected to your transmitter, at the moment it'll appear as HVC45_servo. which is not very exciting. However, we can change the name here. So for instance, if we are using it in a bus configuration, we might have, say, 2 aileron servos per wing. You could call it, for instance, say left underscore aileron underscore 01. So it's the left aileron servo 01. So first servo, or I can make it 02. And obviously you can save that name. And once you save it in the servo, whenever you connect that servo in a bus configuration to the transmitter and you interrogate it from the transmitter, it'll appear with this name. So that can be handy for certain installations. We have an option to reset the servo back to factory default settings, which can be handy. And we've just got a version number for the software here, version 3.02, which I understand is the current version as of today. Down the bottom, we have an open and save feature, so you can save the configuration of a servo. So you might change a whole lot of parameters. We can save that as a file to the PC. We can open that file. So for future use, or if you want to program multiple servos, that can be handy. We have a read option, so that basically reads the actual servo settings. And we have a program option to program the servo. Although some settings I've noticed automatically program the servo, which we'll see in a second. Okay, that's pretty much the info screen. Let's go to setup. Back to setup. Another important thing apart from this indicator here is along the bottom here we've had a horizontal slider. So I can move the servo, as you can see it moving. And more importantly, it gives us an indication of the pulse width, or pulse position, I should say, relative to our normal range that we have for servo. So typically, for most radio systems, 1500 microseconds is the center or neutral position for center stick. That would be like your 0% setting. However, some radios are a little bit different. So most notably for Taba use 1520 microseconds as their center position. A little bit different. So a couple of clicks of trim difference there. Also with this slider, the endpoints equate to 100% or plus 100% or negative 100% throw in your transmitter. So this last indicator here is plus 100% travel on your transmitter, and the other end's minus 100%. Now be aware, on the radio you can actually go all the way to 200%, but this slider only basically gives you the 100% option, which is what we normally only need. Okay, over on the left we have our neutral or sub-trim position, and you'll see there's a whole lot of little negative buttons and a couple of positive buttons. So they're basically an adjustment for this value. So you have a fine adjustment, a mid sort of adjustment, and a coarse adjustment. So coarse adjusts it by 10-degree steps, and this parameter here, if you change it, if you keep changing it, sort of nothing happens. So I'm just changing it here, and you'll notice, but if I stop and wait a second or two, you'll notice it writes it to the servo. So now the servo has been written with a new neutral position of 16.5 degrees. However, I didn't have to hit the program button. So some of these parameters you need to hit the program button, some you don't. Just be aware of that. So let's put in a offset. Oops. Let's put in an offset of, say, I don't know, make it 40 degrees. So you notice the servo horn's now moved to the new neutral position, which is offset by clockwise rotation of 40 degrees. However, this indicator is on 0 degrees, so why is that? Well, basically the new neutral, if you like, is at 40 degrees offset. However, as far as the software is concerned, that's still our neutral or our 0% indication. So at 1500 microseconds, the servo horn has moved an offset of 40 degrees, but really that's our 0% or 0 degree reference point. In other words, our center or neutral position of the servo. So don't get these two confused. And we still have 60 degrees travel set by travel A, travel B. So travel A is clockwise rotation, travel B anti-clockwise. So if I go to the positive 100% travel, the horn moves another 60 degrees offset from that 40. And if I go the other way, you've got 60 degrees back the other way from that 40 degree position. Hopefully that makes sense. I might just reset that back to 0 to make things easy as I explain things. Now these three parameters are also can be set from your core or Atom transmitter screen or the PowerBox mobile terminal. No problems there, and I did explain that in previous videos. However, there's this new parameter here, endpoint A and endpoint B. Now if you remember in your PowerBox transmitter, when you set the servo throws, you have a travel adjustment, which is called way, but you also have a limit, and the limit is basically the maximum throw you can get out of the servo. If you set a limit, the mixing will never ever go past that limit. Well, these endpoint A and endpoint B values are similar, except they apply to the servo in this case. So just to demonstrate it, at the moment for 100% throw on the transmitter, so if I move this up to 2000 microseconds, we have 60 degrees worth of travel. And obviously I can change that, make it say 120, no problem. Let's see what happens if I reduce this endpoint A. So at the moment it's set to the default of 1800 degrees, which is about 5 rotations of the actual servo horn. But let's reduce this value. So let's go down to say, I'll go down to about 100 and I'll go a little bit less. I'll make it 90. Make it exactly 90. At the moment the servo hasn't really done anything different. Let's go to 90.0 because I'm fussy. Okay, so set 90 degrees for this endpoint A. At the moment the servo is set to plus 100% travel, which gives us 60 degrees because that's set by here. Now watch what happens when I increase this. So if I go to 120 degrees, the servo has not moved to 120 degrees. It's actually stopped at 90, and that's because I've set 90 degrees here as an endpoint limit. So basically what this limit, it's a hard limit. It's an electronically adjustable hard limit. So no matter what mixing is set in the transmitter, and no matter what amount of percentage of travel you set in the transmitter, the servo will never ever exceed this value here in this clockwise direction of 90 degrees. So that's handy as a hard limit, and you can set that within this software, but you can't set these two parameters from your transmitter. You need to use the software to set these. So just consider these as a hard limit for the servo. So it can be handy after you set up an aircraft to reduce these limits, so there's no way the servo can actually exceed those limits. So there's no danger of the servo causing any damage to your linkages and that. Alright, and the default is the maximum value of 1800. If we just go up to that maximum, again that's about 5 rotations. So remember, as I showed you in the previous video, we can actually basically keep the servo rotating round and round and round. You've got 5 revolutions in the clockwise direction and 5 in anti-clockwise, so a total of 10 revolutions if need be for whatever weird application you may have. Alright, so I've just changed those back to 60 degrees, endpoint A just set to maximum. I did mention, or did spend a bit of time talking about set neutral and disengage in the previous video. So remember, disengage disables the motor so you can manually move the servo horn, and then you can move it to a position wherever you like, and then you hit the set neutral button, and that saves the new position as a neutral, the new neutral spot. In other words, at 1500 microseconds, we can set a new neutral by physically moving the servo horn. Again, you can turn these on and off from the transmitter screen as well. Direction of operation, that's fairly self-explanatory, and that's another parameter we can set from the transmitter or from the software, so I won't spend any time on that, it's pretty obvious. Here's a new option here, band select. So with some fly barless controllers and some gyros, you can actually run a servo that has or responds to a narrow pulse of 760 microseconds. So the default pulse that we use for sort of 99% of radio systems, the standard is 1520 microseconds. However, we can use a narrow pulse. I know, like Futaba Mikado on their fly barless systems, for instance. You can use the cyclic servos, which are the ones that control the swash plate. You can set them up, the fly barless controller that is, so it outputs a narrow pulse. So with these servos, we can set it to respond to the narrow pulse. Just be aware that if you set this incorrectly, so if you set it to narrow and plug the servo into a normal receiver, for instance, that feeds out 1520, the servo won't work. It won't work properly and you'll think it's faulty. So yeah, just make sure you have the right option selected. Like I said, 95 or 99% of use cases will be using 1520 microseconds. So yeah, just leave it on there. Moving on, speed. So this is basically servo speed. The software maximum is 1800 degrees per second, which the servo can't actually reach that speed. However, we can actually slow it down. Let's slow him down to say, oh, maybe not that slow. Let's go to 60 degrees per second. So I'll hit program that value, so it writes it. So let's move the servo 60 degrees. So we've got travel set to 60. So now it takes about a second for the servo to move. And if I go all the way the other way to minus 100%, that'll give us 120 degrees, so it'll take about 2 seconds. There you go. So this parameter can be adjusted from the transmitter screen as well. And we can also just toggle it on and off. So now we're back to sort of normal speed just by toggling this feature on and off without having to adjust it. So handy where you want to slow the servo down. I did mention the torque and torque delay because these two values here can also be set from the transmitter. So I mentioned these in the previous video. So this is where we can reduce the torque if we need to for whatever reason. And also this new reduced value, for instance, will pertain or basically activate after this delay is set. So you have a delay here that you can set, so the reduction in torque happens after that delay. So you still get an initial quick response of the servo, but then the torque limiter kicks in. So think of it like a torque limiter, which occurs after this delay's elapsed. Okay, let's have a look at the following tab, Advanced. A bit more information in here, a bit more useful information. So first of all, on the left hand side, we've got the P2 bus or the S bus channel that we can set the program servo to. So for instance, I can select from channel 1. So this is the radio channel or the transmitter channel that the servo will respond to when it's connected to a bus system. So I can select any channel from 1 to 26 if I'm using a PowerBox core radio. If I'm using an Atom radio, the maximum channel count is 18. And if we're using it in an S-bus configuration, don't forget that S-bus, the standard for S-bus is 16 linear channels and 2 switched. So realistically, it's a 16-channel system. The 2 switch channels, they pull a few stunts to get the 2 switch channels, but from a standard servo channel, PWM channel operating type of feature, you've only got 16 channels to choose from when running in S-bus protocol. So, yep, again, this parameter we can set from the transmitter as well. Now moving down, we've got this control loop preset, and I did touch on this a little bit when we were watching the previous videos, but now we have a graph that sort of shows it in a little bit more detail. So this particular graph has a horizontal and vertical axis. So the horizontal axis, as far as I can tell, is time. So this is time for the servo. And the vertical axis is either torque or current or a combination of the two, I suspect. They're not labeled, the axes, so I'm not 100% sure, but I'm pretty sure it's sort of related to torque and current versus time across the horizontal axis. So when you purchase one of these servos and take it out of the box, they come set to accurate. So accurate probably gives you the best good old range, good performance across the whole range with good response, but you can fine tune it slightly. And one of the big things is we can adjust the deadband. So the deadband is the time taken basically, or the amount of time, how can I explain this? It's basically the amount of pulse, the pulse width can change X amount before the servo responds. So if the deadband's narrow, you only have to move, say, your stick a little tiny amount, and the servo will respond really, pretty much straight away. Or if you increase the deadband a lot, you can have a little bit of jitter in there, or if, you can move the stick a little tiny bit, hardly noticeable, but you can move the stick a little bit before the servo actually responds. And it's handy where you have linkages which have very little play and very little friction, because sometimes you'll notice on 3D aircraft where the deadband's really tight and you have problems with the servo chattering, especially when it comes to a stop. You might find it doesn't come to a clean stop and it bounces a little bit, chatters a bit, and it hunts for the neutral position because it's overshooting as it tries to find neutral. It overshoots a little bit in each direction, so it keeps hunting backwards and forwards, which is not that great for current consumption because while it's moving, it's drawing power and whatever. But usually when you're in the air, it's not a problem because any sort of wind over the flight surface adds a bit of load to the servo, and that helps reduce that issue. However, we can adjust it here. So we've got 5 options to choose from. We have standard, performance, accurate, torque, and competition. So let's compare accurate with, say, standard, and let's see how the graph changes. So we've got accurate. I'm just going to go pick standard now. So notice the graph's moved a little bit. Let's go back to accurate and now to standard. So I want you to pay attention to this little horizontal gap in the middle here. So when we're in standard, there's a little bit of a gap. Hopefully you can see that in the video. If I go to accurate, you notice the gap narrows. So the deadband is a lot less when we have accurate selected. As a matter of fact, if we just look at this center bit here, in standard it uses a wider deadband. Performance uses about the same deadband. Accurate uses a much tighter deadband. When we're in torque mode, that uses a wider deadband, and in competition, we've got a narrow deadband. So the 2 options for narrow deadband are accurate and competition. Let's see what else changes. So I'll go back to accurate. Let's take a look at this slope here of this section of the response of the servo. So there's accurate. Let's go to standard. So if you notice in standard, the slope of this line's a lot less. Let's go back to accurate. Accurate's a little bit steeper. Standard. So when you're using it in standard versus accurate, in standard mode, basically the torque, the slope of the torque, in other words, the response of the torque output takes a bit more time. So in other words, if you move the servo, if you go, say, from low stick to high stick or mid stick to high stick, the servo's torque response is not as quick as it is when you're in accurate mode. So accurate will give you sort of faster torque ramp up, if you like, as compared to standard. And you think, oh, well, I need maximum, so, select accurate. But it's not always the case. You don't, because there's a trade-off, because all these servos rely on feedback, and they use a control mechanism. So you can have a super duper fast servo, but it might not be super accurate as far as stopping and all that. So there's always a bit of a trade-off when you select these sort of options. There's no one perfect option for every single linkage type configuration. So it's handy to note that standard will give you like a slower torque ramp up versus accurate. And if we go to performance, you'll notice performance is very similar to accurate as far as the slope is concerned. There's not much difference. The main difference between performance and accurate is really the deadband, the change in the deadband. So accurate has a tighter deadband, whereas performance, that's standard. Performance will give you a reasonably fast torque response, but with a looser or looser deadband, if you like. Now, accurate and torque. Let's see what happens when we select torque. Again, not a huge change, but you'll notice in torque, this curve is now steeper again. So obviously when we select torque, have a slightly looser deadband, but the main adjustment here is that the torque response has a steeper response. In other words, the torque will ramp up a lot quicker, the current to the motor will ramp up a lot quicker, so the servo can respond to loads a lot better. We do have a slightly looser deadband here, and that's to control a bit of overshoot, I suspect. So just be aware of that. And then competition, if I go to competition, we have a little bit less torque. So if I compare it torque and competition, you see in competition mode we have a little bit less slope on here. So that's very similar to accurate. So accurate and competition are virtually identical. So there's competition and there's accurate. There's not much in it between those two settings. So it'd be interesting to see if you could actually notice it in practice, because there's not a lot of difference. So the main ones that are different are the torque, standard, and go back to accurate as well. So again, you can adjust, you can select the setting. So for instance, a lot of times you might favor like a looser deadband if you had trouble with the linkages. Then you can select, say, instead of using accurate, you might want to go for performance, or if you want, you could even probably use torque, because that's got a wider deadband as well. If you're in a situation where you want, full-on outright torque by sacrificing a little bit of accuracy, you can select torque. So maybe, for instance, if you're using it to, to lower some landing gear or some mechanical linkage which needs a lot of instantaneous torque, then you could select that option. So just be aware that selecting some of these higher output settings will increase the draw of the servo, the current draw, power dissipation and all that. So just be aware of that. It's well within the capabilities of the servo, so there's no problems there, but just something to be aware of. Yeah, so I suggest you have a play with all these 5 settings. Whether you notice a lot of difference in practice, we'll see. You have to be a really good pilot. Anyway, moving on. What else do we have? We've got this error sound monitor. I won't explain this because I don't know what it does. I've played with it. I need to ask Richard to ask him to see what this box does, but at the moment, a bit of a question mark on this. I suspect it could be that when the servo has some sort of weird error, it might be able to create a sound, because the servos can actually create sound with the motor windings. And I think Futaba do it as well. They can actually send a sound pulse to indicate certain things with their servos, their S-bus servos. So this might be something similar, but don't quote me on that. Moving on to soft start, I'll go across to the screen over here. So soft start, we can turn it on and off. So this is a setting we can turn on and off from the transmitter screen as well. However, in this software, we have a couple of additional options. We can actually change the soft start speed. We can slow it down even further, make it really, really slow, like 6 degrees per second. We can also play around with the torque. We can decrease the torque or increase it. So 2 more adjustments available. Soft start's a really nice feature to have with these powerful servos. I quite like it. So yeah, a couple of options we can program. Again, once you set this in the servo, it keeps those settings pretty much forever until you override them. So yeah, so just be aware from the transmitter we can turn it on and off, but we can't adjust the speed or the torque. You need the PC terminal, this new iServo PC terminal, to do it. And last but not least, we have fail-safe mode. So just to refresh everyone's memory, with S-bus, also P2 bus type servo configurations, the fail-safe information has to be stored within the device that's at the end of the chain. So in this case, if you've got a whole bunch of servos, you actually have to store the fail-safe information in the actual servo. So these new servos have that ability, and we have a couple of options. So we have lock last position. So this is typically referred to as hold. So when you set the transmitter to fail-safe hold, it's the same thing, lock last position. We have also program position. So that's where we tell the servo to go to a particular spot in its rotational spot, wherever you want it to go, 10 degrees, 20 degrees, 60 degrees, throttle close. So normally I'd use that with my engines. So normally when I have fail-safe active, I kill the throttle. I basically kill my turbines or my internal combustion motors all go to 0 throttle. That's what I prefer from a safety perspective. So I'd use this program position option to do that. Now you can set these two from your transmitter. However, we have a couple more options which you can't set from the transmitter. So one is program with speed. So another option here that we have is we can set a program position and we can tell the servo to move to that position when we're in failsafe using a particular speed. So for instance, you might want to slow the servo down to go to that position for whatever reason. You have that option. There's also motor free and motor braking. I haven't actually tried these. I suspect motor free means the servo motor doesn't have any torque if it's in the free position. I need to try this, but it's a bit like you know, if you go into failsafe and for whatever reason you don't want the servo motor to drive anything, you'd probably select this motor free position. Something to try. There's also motor braking, so I'm not sure how that works, whether it uses back EMF control. Again, I haven't played with these two settings, so I need to play with them. However, they're there for someone else to play with. And of course, you can set the speed and the fail-safe position here, depending on which modes we've set. So remember, lock last position, that's basically fail-safe hold. They haven't called it hold here, they just called it lock last position. Now, moving on, we have 3 boxes here. Now these are a bit odd because these 3 boxes are not parameters that we can save in the servo. So I've tried saving them, but it doesn't save them. Basically what happens is they only stay active while the servo's powered up via the software. And you think, oh, what good is that? Well, it's sort of used in conjunction with this telemetry screen. So this telemetry screen is a telemetry screen that can be used while the servo's connected to the PC. So have a little servo tester here. So we can move the servo. It'd be nice if we had an automatic backwards and forwards option as well. Maybe they can include that in a future version of this software. So you could click a box and have the servo alternate backwards and forwards automatically. That'd be a handy feature for testing servos. We have the position indicator. We have a rate indicator as well. So you might notice the rate indicator moves to indicate how fast the servo's moving. We have a couple of alarming type boxes here. So we've got correct input voltage, blue tick, normal temperature, blue tick, load exceeds torque threshold, blue tick, mechanical system operating normally, blue tick. Okay, what are the, what use are these? Well, again, I suspect this screen here, as well as these parameters here, were for the PowerBox development team when they were developing or testing these servos, so they could change various parameters and monitor them from this software. So that's where the use of this telemetry feature comes in, is because the servo needs to be connected to this software to actually operate all these functions here. It's only really good for testing on the bench. So I could connect the servo up to some linkages and a load and then sort of monitor it from here. And just to give you an idea, for instance, at the moment we've got correct input voltage is blue. If I go back to the advanced screen, let's change the maximum voltage. Actually, before I do that, if you look at my battery voltage going to the servo, it's about 7.3 volts. So let's reduce this maximum voltage to below 7.3 volts. Let's go to 7 volts. And let's go back to the telemetry screen and see what's changed. So now you notice I get a warning triangle saying warning, over voltage detected. So it's not going to damage the servo because the servo can handle 7.3 volts. But however, the telemetry screen's giving me an alarm indicating, hey, the value for the voltage that I've set here has been exceeded. It's out of limits, so it's giving me a warning. So that's why I suspect that these 3 boxes here, these parameters here, have been used by PowerBox themselves when they were testing servos, putting them through their paces. So they can set various torque limits, temperatures, voltages, and this bind relief. I'm not sure what bind relief is. And then they could raise an alarm if that limit was exceeded when they were testing. And again, you can see temperature, battery voltage, and current. We're not drawing much current because I don't really have much load in it. So this screen, this telemetry screen here, is probably only useful to PowerBox, or if you're performing some test at home on the bench, putting the servo through its paces, then you can sort of test it using this telemetry screen in conjunction with these parameters here. So yeah, that's about it. The big thing is, just quickly, briefly go over the differences between this software program and setting it up on your transmitter is these endpoint adjustments. Remember this hard limit I was talking about? So we can set that in here. You can't set this in the transmitter or even the mobile terminal. We have the option for a narrow pulse width. Not really a super duper useful feature, but handy for some, especially possibly if you're using a heli, a fly barless controller, etc. All these options are settable from the transmitters. So that's the only one here, the only other one here on this screen that cannot be set from the transmitter. And then these parameters here, we're not really too worried about that. And the other option, the soft start, we can set the speed and the torque. So there's two additional parameters for the soft start. So not only can we turn it on and off from here, as you can from the transmitter, we can also set the speed and torque, which you can't from the transmitter. And with the fail-safe position, you have a couple of extra options. We have program with speed, motor free, motor braking. So you can't set these other options through the transmitter. And you can set the fail-safe speed and position as well through here, although we can sort of do that. You can set the position from the transmitter but not the speed. So a couple of handy little options there for those that want to set their fail-safes correctly. And that's about it. Info screen, I did mention the mechanical runtime, so that might be a really handy feature just to keep track of the lifetime of the servos, how much work they do. Probably not so much how much work they actually do, because you don't know if the servo's been driven hard or easy, have an easy life or a hard life, but it gives you an idea of how long the servo's been in use for, I suppose. Okay, well hopefully that's covered most questions for this software. Like I said, if you have one of these servos or more, good idea to download the software, have a bit of a fiddle with it, and hopefully you've enjoyed this particular video. And we'll catch you on the next video. I'll set up some multiple servo arrangements on a P2 bus configuration, and we'll have a look at some of the intricacies when we do that and what to look out for, because some people have trouble, have issues connecting multiple servos to the bus, things like not looking after addresses and all that sort of stuff. Anyway, we'll catch you on the future video. Talk to everybody then. Thank you all for watching.